Perhaps all of you would remember from your science classes in junior high school that acceleration is defined as a change of velocity per unit time. That is correct, as it is our conceptual definition of acceleration. However, nothing was said about what causes such change of velocity and therefore causing an object to accelerate, right? To answer this, let us relate the concept of acceleration in the first law of motion we discussed previously. Again, Newton's first law states that an object traveling in a straight line remains at constant velocity unless acted upon by external unbalanced force. It is safe to say then that if an external unbalanced force is required to produce a change in velocity, then an external unbalanced force causes acceleration, right? Our scientist Newton was very much aware of this, so he related acceleration to inertia or mass. We can remember that inertia is the tendency not to undergo a change in motion. A reasonable assumption is that the greater the inertia or mass of an object, the smaller the change in motion when force is applied. Such observation became a law and eventually named as Newton's second law of motion. We can describe second law in terms of how unbalanced force acting on an object affects acceleration. This law states that the acceleration produced by an unbalanced force acting on an object is directly proportional to how great that force and if that force is parallel to the object. In simple words, we can say that the higher the force we exerted on an object, the greater its acceleration. Also, this law states that the acceleration of an object is inversely proportional to its mass. Or simply put, the greater the mass of an object, the smaller the acceleration. Commonly, we represent the second law as F is equals to ma, where F is the force, m is mass, and a is acceleration. Let us have a descriptive illustration of these relationships. Here is a man exerting a force F at an object with a mass m. Notice that in this figure, the unbalanced force from man's pull produces an acceleration to the object. Say, he was seen by his friend and together, they pull the object. The mass is the same, but the force is doubled, assuming both of them exert the same amount of force. This will have result greater acceleration, doubling the acceleration compared when the man pulls it alone. Now, for some reason, the girl left the man, and he has to pull two masses. With the force that he alone exerts, the acceleration is reduced by 1/2 when the mass is doubled. I hope this leaves you well with a clear idea about second law of motion. Let us apply this in a problem. Forces are applied to blocks connected by a string and resting on frictionless surface as illustrated in this figure. If the mass of each block is 1.0 kg and the mass of the string is negligible, then what is the acceleration of the system? Let us look first at the diagram. It shows here that both objects have mass of 1 kg. These two objects are opposing with one another. The first object exerts a force of 5 newtons going to left, so we will assign this as negative 5 newtons. Keep in mind that force is a vector quantity, and therefore, we need to identify its direction. Since this is going left, it is going to negative direction. Same when an object is going to south direction. The second object, m sub 2, exerts 8 newtons at positive right direction. So, we will assign our vector as positive 8 newtons. What we want to do is to find acceleration. The common problem with the students in computing physics problem is when they see numbers and they think they can apply this in a formula. Their automatic response is to substitute the values without checking if the units are standard in the metric system. We are lacking this question because all units are standard units. Kilogram for mass and Newton for force, but keep in mind that when you encounter quantities with different units, we need to convert them. We already had unit conversion in our previous video, but I will post a link below in case you need a refresher. What do we do next in this problem is to calculate the acceleration using our equation F is equal to ma. We can derive this formula as A is equal to F over m. Let us substitute the given now. We have two forces and we need to find the resultant force. They are anti-parallel vectors, if you can remember, because they are heading towards opposite direction. We can simply add them. 8 newtons plus negative 5 newtons is equal to positive 3 newton. Since it is positive, our vector sum is going east. After getting the force, we may want to find mass. Since we have two given masses, the total mass of the system can be computed by getting their sum. So total mass is 2 kilograms. We perform the operations now. 3 newtons over 2 kilograms is equal to 1.5 meter per second square. Therefore, the acceleration of these two objects here is 1.5 meter per second square going to east direction. While F is equal to ma is a simple equation, we must use it cautiously. First, we must be certain about which body we are applying it to. The force here is usually referred to as the net force, which is the total force acting on that body, like in our previous example. That means only force that act on that body are to be included in the vector sum, not forces acting on other bodies that might be involved in the given situation. To make it clear, for example, if you are playing sports, say rugby, the net force on you is the vector sum of all pushes and pull on your body. It does not include any push or pull on another player from you or from anyone else. Okay? So every time you work a force problem, your first step is to clearly state the body to which you are applying Newton's law. I will be providing more examples of how we compute acceleration, especially when two or more forces acting on a body or when force is directed at a certain angle in the next video. I'm Gilmar De Castro, and see you in the next video.